A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Today we are going to discuss raw materials, flow sheet diagrams and unit operations and unit processes of formic acid industry and its applications. So today we are going to discuss the production, a few points, few processes we have discussed before, and methyl formate hydrolysis we have discussed, production from formates we have discussed in the last lecture, formic acid from carbon dioxide we have also discussed in the last lecture, and formic acid from biomass was also discussed in the last lecture. Now today we are going to discuss the method byproduct of acetic acid production and other processes just by name I have mentioned, and then will be the recovery of formic acid, and then will be the topic uses. Okay, now we are going to discuss the synthesis production of formic acid as a byproduct of acetic acid production. Significant amount of formic acid is produced as a byproduct in the manufacture of other chemicals. At one time, acetic acid was produced on a large scale by oxidation of alkenes, so by a process that co-generates significant formic acid. So at one time, when there was oxidation of alkenes was taking place for the manufacture of acetic acid, so in this process the formic acid was also used to be generated significantly. So this was one way for the manufacture of formic acid also at that time. This oxidative route to acetic acid is declining in importance, so that the aforementioned dedicated routes for formic acid have become more important. So but nowadays, as we have seen the production of formic acid by different other ways, like from methyl formate or from formate salts and from carbon dioxide. So this method is declining in its importance. So now other improvement and developments are making their importance rather than this method. Other processes which are used for the manufacture of formic acid are oxidation of formaldehyde and coupling of methanol. There are some other laboratory processes also, but as we are concerned with industrial processes according to our syllabus, so I have discussed all the processes which are being used or which have been being used industrially, and the unit processes, most probably the unit processes which are taking place in those industrial processes, unit operations, all these. So till here we have done all the production processes of formic acid. Now we are going to discuss in the next one how to separate or recover formic acid. Now students, we are going to do the recovery of formic acid. So the method which is used for the recovery of formic acid is azeotropic distillation. Formic acid water mixture cannot be concentrated to more than the azeotropic composition by simple distillation. What is an azeotrope? First question in this aspect. An azeotrope or constant boiling point mixture is a mixture of two or more liquids whose proportions cannot be altered or changed by simple distillation. This happens because when an azeotrope is boiled, the vapor has the same proportion of constituent as the unboiled mixture. Now what's there? Now you are having two, like as is the example formic acid and water, you are having two solvents, two or more liquids, and if when you're doing the distillation, both of them are having the about very close vapor pressure. So when they're boiled, when they are boiled, their vapors nearly have the same composition as their unboiled mixture. So azeotrope is a constant boiling mixture. You cannot separate them easily. This happens because when an azeotrope is boiled, the vapor has the same proportion of constituents as the unboiled mixture. Because their composition is unchanged by distillation, azeotropes are called, especially in older texts, constant boiling point mixtures. Now, as far as this specific case is concerned, so azeotropic distillation we do. Now, what is azeotropic distillation? First of all, just consider the boiling points of water and formic acid. Boiling point of water is 100 degrees centigrade and boiling point of formic acid is 100.8 degrees centigrade. So whenever they are together, they are in the form of mixture, they will be coming up at the same temperature, like at 100 degrees centigrade or near 100 degrees centigrade. Both of them will be coming in certain percentage, and you cannot separate them. One of them will be whose boiling point is less. For example, water will be boiled up before, but that will be containing you cannot get it more pure, for few of the vapors of formic acid will also come along with that. So azeotropic mixture cannot be distilled by simple distillation. So we use azeotropic distillation. So what is that azeotropic distillation? We are just going to go through the next slide, which will be explaining how azeotropic mixtures are separated, and now we will use the term azeotropic distillation. Now, azeotropic distillation is a process to break azeotrope where another volatile component called the entrainer, the solvent or mass separating agent, is added to form a new lower boiling azeotrope that is heterogeneous. Now, entrainer is what? Entrainer refers to separating agent used to enhance the separation of close boilers or azeotropes by azeotropic or extractive distillation. Now, what is azeotropic distillation? Some solvent, another volatile component that can be a solvent or mass separating agent is added to the azeotrope, so that azeotrope will be broken down, and the component which we want to purify will be making another interaction with this new introduced solvent or mass separating agent. Now, entrainer is basically is used in both azeotropic and or extractive distillation. Now, if there are two close boiler solvents, not solvents, liquids. If there are two close boiler liquids and we want their separation, like as we are giving the example of formic acid and water, so we can use an entrainer. We can use the separating agent. That can be a solvent, that can be a mass separating agent. We can add it to separate over azeotropic mixture, because azeotrope will be broken down, and that is when we add a third party that can be a solvent or that can be a mass separating agent. The concentration of formic acid in the azeotropic mixture increases if the distillation is carried out under pressure. Now you should know the theory of the boiling point. Now remember that boiling point is the temperature at which the vapor pressure of the liquid that is being boiled, that is being heated, the vapor pressure of the liquid becomes equal to the external vapor pressure. External pressure. Vapor pressure of the liquid becomes equal to the external pressure. अब बॉइलिंग पॉइंट का रूल है, अगर आप प्रेशर को, एक्सटर्नल प्रेशर को कम करेंगे तो चीज़ कम टेम्परेचर पे बॉईल हो जाएगी, बिकॉज उसका वेपर प्रेशर जल्दी इक्वलाइज हो जाएगा बाहर वाले प्रेशर के साथ। अगर आप बाहर एक्सटर्नल प्रेशर बढ़ा दोगे तो वो चीज़ ज़्यादा टेम्परेचर पे बॉईल होगी। You can grasp this concept by the cooker pressure. Like in the cooker pressure, in the pressure cooker, what happens? You put pressure, you put weight on the cooker. So what happens then? More heat is required for the contents inside, whose vapor pressure will be equal to the external pressure which you have given by putting weight on the cooker. Now more heat will be required. The things which will be inside, like if it is meat or it is beef or whatever is it which is inside, will be heated, will be absorbing more heat, and that will be cooked very well. So now if you increase the pressure, what happens if you increase the pressure? The boiling point of the mixture will automatically increase. So but at that increased boiling point, the distillate which we shall get will be having more concentration of the formic acid. But higher boiling point at higher pressure, it increases the decomposition rate of formic acid. So that is not a very much appealing technique to just increase the pressure and then separate the formic acid and water azeotropic mixture. So a number of trainers have been proposed for azeotropic distillation. So here we see in this slide the azeotropic distillation. We are introducing another solvent. Entrainer we are actually introducing, and with the help of that entrainer we are separating over azeotropic mixture. That mixture will be, azeotrope will be broken down in that case. Now what happens in extraction? Several technologies have been developed in which reactive extraction is used to transfer formic acid to a separate organic phase, or formic acid is bound to a weak complexing agent in water phase. Now there are two options. If we are transferring the formic acid into a separate organic phase, or we are bounding, binding over formic acid with a weak complexing agent. In both cases, the azeotrope can be avoided, like it will be broken down, the water will be separated from formic acid. When the phase separation is involved, it is possible to reduce the total amount of water that needs to be evaporated. When we shall be doing the phase separation, you know what is the phase separation? For example, if you are having formic acid water, you are adding an organic solvent. In that case, if you are adding an organic solvent, formic acid is having more affinity with that organic solvent. It will move into the organic solvent. Most of that, very less amount of formic acid will remain in the water. So when you will separate both layers, organic and aqueous, the organic, as you do in the separating funnel, both layers are separated from each other, aqueous and organic layer. When you will do what? You will remove the aqueous layer from by the help of separating funnel, and there will be only organic. There will be only organic layer will be left in the separating funnel, or most probably in both of the layers, water is this depends upon the density of the layers, which will be above and which will be below. Most of the time organic layer is down in the separating funnel, and the aqueous layer is above the organic layer. So when we shall remove the downwards, whatever is that depends upon the density downward in the separating funnel, if it is organic layer or aqueous layer, but we can separate both of them. So in this way there will be very less amount of water if we are doing the phase separation of the formic acid. Now as far as extractive distillation is concerned, that is the distillation in the presence of miscible, high boiling, relatively non-volatile component in the solvent that forms no azeotrope with other component in the mixture. So this is a general term, extractive distillation. What is happening in the extractive distillation? We are doing the distillation in the presence of a miscible, high boiling and relatively non-volatile component, which is that solvent that forms no azeotrope with other component. So this is extractive distillation by definition. Now we shall see how we can understand the concept of extractive distillation with the reference of our azeotropic mixture. In the next slide we shall check that. Now this method is used for mixtures. Extractive distillation is used for the mixtures having a low value of relative volatility nearing unity. Now as you know that what is the boiling points of the volatility of these two water formic acids are quite close to each other. Usually secondary amines or tertiary amines are used for the extractive distillation. So the extractive distillation in the extractive distillation of formic acid formic acid is extracted in a distillation column by means of a basic extracting agent which is introduced counter-currently and fed into the bottom of the column. If this mixture is heated in a column downstream, the formic acid is liberated from the salt like a duct and distilled. So now you can check in the diagram. On the left hand side there are two columns, K1 and K2. In K2 you are adding A plus B, two liquids. When this you are also adding E in that. What is that E? So in the case mixture component A and B are separated in the first column through the solvent E recovered in the second column. So now you are adding up a solvent E here. So what will be solvent E and B will be like A will be going away with the help of distillation, and B and E, the solvent, will be together going into the next column. When they will be collected from the bottom, they will be going into the next column. They will be separated over there. Now just pick that concept and paste it on your extractive distillation of phases extracting agent, that basic extracting agents you are using here. Now you are having mixture formic acid and water in column A, and now you are using a basic extracting agent which you have given. The example are usually secondary amines or tertiary amines. You are introducing it counter-currently and fed into the bottom of the column. Counter-currently, for example, if you are doing the distillation and you are adding A and B from the bottom, so you can add the basic extracting agent, you can introduce it counter-currently, and that is fed into the bottom of the column. So for example, here the E, which is the E which is labeled as the miscible liquid, which they have solvent, miscible solvent they have said. But now we are adding here extracting agent, basic extracting agent. So this mixture, what will be that basic extracting agent will do? This will be making an adduct with our formic acid. Formic acid as will make an adduct, of course the boiling point will be much higher in that case. If it is making an adduct with secondary amide or tertiary amide, so water will be boiled up and it will be going away. But the basic extracting agent and the adduct of formic acid and basic extracting agent like tertiary amines or amides will not be boiled up. So that shall be collected at the bottom of the column. Now you can see that they are going to K2. They will be sent or fed into K2 in the second column. And we know that we have studied in the previous slides that if we heat up that adduct or mixture more than 150 degrees centigrade, they are separated from each other, formic acid and adduct. So the mixture is heated in a column downstream. The formic acid is liberated from the salt like adduct and distilled. So So if the mixture is heated, for example B plus E, we have sent them to the next column and we are heating them, so both of them will be separated in that case. So we shall then again, for example, distill. Formic acid is of course having lesser boiling point as compared to the tertiary amine or secondary amine. So did you get the point? What have we done? Simply if I say I was having a mixture of A and B, I have added an agent, basic extracting agent. B did make an adduct with that. A was just distilled because B plus adduct has having a high boiling point now. They have been sent to the next column, and when heat is given to them, they are separated. And when the distillation is done, B of course is having lesser boiling point, so it has been distilled away. So this is the way in which we can extract formic acid with the help of extractive distillation. So the main difference between the two is in the process of separating the mixture. So azeotropic and extractive distillation is just the difference of separating the mixture. In extractive distillation, a specific separation solvent is used in every mixture that should not form an azeotrope. In this way, extractive distillation is a better and easier method than azeotropic distillation. So if we compare the both distillations, so as far as the common use is concerned, azeotropic distillation is less used, but extractive distillation is more used. If energy consumption is concerned, azeotropic distillation will be consuming more energy as compared to the extractive distillation, because in the extractive distillation what shall be done, as we have discussed the adduct of tertiary amine or amide, what will be over there? They will be just heated above 150, they will be separated from each other. Solvent that is coming out, solvent that will be coming out in the azeotropic distillation, as we have seen in the diagram at the previous slide, that was solvent was coming up from the top, but in the extractive distillation the solvent is coming out from the bottom, as we have discussed that in the solvent in the extractive distillation the solvent comes out from the bottom, as we have seen in the extractive distillation of adduct of formic acid and amine. Flexibility of solvents, less flexibility of solvents in the azeotropic distillation, but more flexibility of the solvents is there in the extractive distillation. So students, now we are going to do the uses of formic acid. Because of its acidity, its aldehydic nature and reducing properties of formic acid, it is being used in variety of fields. In contrast to the mineral acids, formic acid evaporates without leaving any residue. आपके पास अगर कोई मिनरल एसिड हो, आप जब उसे इवेपोरेट करोगे, फॉर एग्जांपल कोई भी होगा HCl या कुछ भी और होगा, तो कुछ ना कुछ उसके अंदर जो है वो कुछ ना कुछ रेजिड्यू बच जाता है, बट फॉर्मिक एसिड सारे का सारा इवेपोरेट हो जाता है, लिविंग नो रेजिड्यू. In Europe, most of the formic acid is used in the feed industry and as a silage aid. Estimated consumption in various applications is listed in the table here. यहाँ आपको टेबल नज़र आ रहा होगा. तो यूरोप की वैसे बात कर रहे हैं कि यूरोप में फॉर्मिक एसिड जो है ज़्यादातर फीड इंडस्ट्री में और साइलेज एड के तौर पे, यानी जो फीड को प्रिजर्व करते हैं ना, उसके तौर पे जो है वो यूज़ किया जाता है. साइलेज की आगे डिटेल आ जाएगी तो आपको पता लग जाएगा. अब एप्लीकेशन ऑफ फॉर्मिक एसिड का जो आप टेबल देख रहे हैं उसमें ज़रा परसेंटेज चेक कीजिए. सबसे ज़्यादा साइलेज और एनिमल फीड में यूज़ हो रहे हैं 27%, लेदर एंड टैनिंग में 22% यूज़ हो रहा है, फार्मास्यूटिकल एंड फूड केमिकल्स में 14% यूज़ हो रहा है, फिर टेक्सटाइल में 9% यूज़ हो रहा है, नेचुरल रबर में 7% यूज़ हो रहा है, ड्रिलिंग फ्लूइड्स में भी यूज़ हो रहा है 4% और मिसलेनियस के यूजेज जो है वो 17%. तो अब अगर हम देखें कि फर्स्ट यूज़ में जाते हैं जो है बायो प्रिजर्वेशन. बायो प्रिजर्वेशन एज द नेम इज शोइंग दैट वी आर biomass preservation, we are preserving some biomass. First of all, in the biomass preservation is the silage. Now, what is silage? The term silage traditionally refers to ensilation of forage crops, mainly grasses, or for feeding bovines on farms. अब feeding bovines होती हैं जैसे हमारे ये जो गाय बफलो भी इसमें आती है, यॉक वगैरह, और इसमें बहुत से जो है वो बोवेंस में आते हैं. तो ये जो हमारे फार्म्स के ऊपर ये जो बेफलेज होती हैं या इस तरह के जो भी पेट हमारे हैं, यॉक वगैरह जो भी हैं, ये सारे के सारे इनके लिए फॉरेज क्रॉप्स जो होते हैं, मतलब ग्रासेस वगैरह होते हैं, इनके एनसाइलेशन की जाती है. ठीक है, तो ये एनसाइलेशन जब इनकी की जाती है, इनको साइलेज के तौर पे प्रिजर्व किया जाता है, रखा जाता है, तो इसको साइलेज बोलते हैं. द टर्म साइलेज इज रेफरिंग द एनसाइलेशन ऑफ फॉरेज क्रॉप्स. इसकी डिटेल हम अगली स्लाइड में देखते हैं. नाउ व्हाट आर बोवाइन्स? The biological subfamily Bovini includes a diverse group of 10 genera of medium to large size ungulates, including domestic cattle, bison, African buffalo, the water buffalo, the yak, and the four-horned and spiral-horned antepoles. Now, so silage is prepared for bovines which are present on the farms. Now, the consumption of this silage is dependent on the climate. Now, formic acid based ensiling is especially suitable for wet conditions. Northern Europe is the main consumption area where ensilage is made up with the help of formic acid. No, so the formic acid based ensiling is especially suitable for wet conditions, which are being used in the Northern Europe. Now, ensiling is based on fermentation under anaerobic conditions, where the lactic acid produced by lactic acid bacteria preserve the silage. Now, what is happening? Ensiling is basically the preparation of the silage, and how this ensiling is being done? This is being done by the fermentation under anaerobic conditions. So, what is the result of that fermentation under anaerobic conditions? The result of that fermentation under anaerobic condition is the production of lactic acid bacteria by lactic acid. Now, these lactic acid bacteria, which are prepared by the lactic acid as a result of the fermentation under anaerobic conditions, is protecting or preserving the silage. These bacteria, lactic acid bacteria, are preserving the silage. Now, just to have a review of the fermentation, so the concept should be reviewed from the may you have studied or not. Fermentation, general concept of fermentation, all of you have, but specifically, by definition, fermentation is a metabolic process metabolic process, the process which is going within the metabolism. It is a metabolic process in which an organism converts a carbohydrate such as starch or a sugar into an alcohol or an acid. So the carbohydrates, or for example starch or sugars, are being converted into alcohol or an acid. This is being happening. This is happening in the fermentation process. Now, for example, yeast performs fermentation to obtain energy by converting sugar into alcohol. Yeast or different enzymes are performing fermentation. Now, the yeast, what the fermentation yeast is performing, that is obtaining energy, and which is released in this process. That is obtaining energy by converting sugars into alcohol. When sugars are converted into alcohols, this is energy is released, and this energy is being used by the yeast. So yeasts are performing fermentation. So ensiling का जो process है, हम कह रहे हैं कि वो anaerobic condition में fermentation होती है ensiling में, ठीक है. ensiling जब हम कर रहे हैं, हम जब silage बनाना चाह रहे हैं, तो उसमें जो है वो लैक्टिक एसिड के बैक्टीरिया लैक्टिक एसिड प्रोड्यूस करता है. तो इस तरह से ये जो हमारे फॉर्म्स के ऊपर बॉविन्स होती हैं, बॉविन्स जो होती हैं कैटल्स, डोमेस्टिक कैटल्स या बफलोस वगैरह, वो जो हैं उनको जो है वो उनके लिए साइलेज प्रिपेयर किया जाता है. The lactic acid lowers the pH and thus prevents unwanted microbial growth. So lactic acid is lowering the pH, so whatever growth is being done by some of the microbes, some of the bacteria, that is prevented in this way. Addition of formic acid results in a rapid initial drop in pH, which promotes the growth of lactic acid bacteria and suppresses the growth of bacteria that produce undesirable compounds such as butyric acid. So what is happening? The addition of formic acid is dropping the pH rapidly. There is a rapid initial drop in the pH, in which is promoting the growth of lactic acid bacteria. The bacteria which were produced by the lactic acid, lactic acid bacteria produce lactic acid, so that is beneficial for the formation of silage. So lactic acid bacteria, the growth of lactic acid bacteria is being promoted by the rapid initial drop in the pH, and the rapid initial drop in the pH is suppressing the growth of bacteria that produce undesirable compounds such as butyric acid. So the formic acid is doing what? The formic acid is doing a rapid initial drop in the pH and promoting the growth of lactic acid bacteria and suppressing the growth of bacteria that produce undesirable compounds such as butyric acid. When the pH drop is enhanced with formic acid, spontaneous fermentation is restricted. हम रोकना किस चीज़ को चाह रहे हैं? Spontaneous fermentation को. What is spontaneous fermentation? Spontaneous fermentation जो होती है वो वाली fermentation होती है that is naturally occurring with different type of wild yeast and microorganisms. So ये naturally होती जा रही होती है, इसके लिए हम कुछ खुद introduce नहीं करते. Naturally it is happening, and in the days of old this was the only type of fermentation that was known. पुराने ज़मानों में सिर्फ यही fermentation थी. And advantages of all of these, like addition of formic acid, increase in the growth of lactic acid bacteria, and decrease the suppression in the growth of bacteria that produce undesirable compounds such as butyric acid, and the drop in the pH which is restricting the spontaneous fermentation. All these advantages, all these things are giving an advantage of more residual sugar and protein. So the silage, if we want more residual sugars and proteins in the silage, we have to do all these things. We have to add formic acid. This will be the advantage of formic acid. By the growth of lactic acid bacteria increase, but the increase in the growth of lactic acid bacteria, but decrease in undesirable bacterial growth. Now, aerobic and anaerobic environments. Aerobic environment is characterized by the presence of free oxygen, while an aerobic environment lacks free oxygen but may contain atomic oxygen bound in compounds such as nitrates, nitriles, and sulfides. So what is the difference between aerobic and anaerobic environments? Where there will be free oxygen, that will be an aerobic environment, and where there will be lack of oxygen, lack of free oxygen, that will be an aerobic environment. But there will be lack of oxygen, but there will be other oxygen bound compounds may be available, that nitrates, nitrites, sulfides. Now the restriction of fermentation is known to have a positive effect on voluntary intake in dairy cow feeding, and thus enhances the milk production. What is happening? The silage which is produced under restricted fermentation, we have given the conditions. We have added formic acid to restrict fermentation, the natural fermentation which is taking place. So that fermentation is restricted, and the production of undesired butyric acid-like compounds or undesired bacteria is also restricted. So if this silage is taken by the dairy cows, so they intake this one silage, this enhances their milk production. There is a positive effect of this silage, this feed on them, on the dairy cow. Forage crops such as grass, corn, clover and alfalfa are cut and chopped and then fermented in silos or bales covered with an airtight film. Now what are the silos or bales? First of all, the forage crops like grass, corn, clover, alfalfa, they are cut, they are chopped. कट किया, उनको चॉपिंग की उनकी और मज़ीद उनको छोटे बनाया, and then fermented in silos or bales are covered with an airtight film anaerobic conditions देने के लिए, and उनको ferment करना है silos or bales में. Now what are the silos? Silo is a structure for storing bulk material. Silos are used in agriculture to store grain or fermented feed known as silage. अब silos में ये जो storing की जाती है जहाँ पे bulk materials की, जैसे cotton के silos आपने कभी देखे होंगे, ऐसे रिंग सा बना होता है गोल सा, एक दूसरे के ऊपर एक लेयरिंग उसकी बना दी जाती है. तो silos are used in agriculture to store grains or fermented feed. This is known as silage. इसके अलावा silos आपने cotton bales आपने देखे होंगे, bales, those are silos, bales or silos. और इसके अलावा गंदम के वूस जो होता है वो कभी कभी बड़े बड़े स्टोरेज की जगह बना के उसको कवर कर दिया जाता है ऊपर से मट्टी वगैरह का लेप देके. तो दैट इज साइलो और बेल, दोज आर साइलोज और बेल्स. Now silos are commonly used for bulk storage of grain, coal, cement, carbon black, wood chips, food products and sawdust. इन सारों को मोस्टली साइलोज की फॉर्म में जो स्टोर किया जाता है. फॉर्मिक एसिड इज एक्सीलेंटली suited to ensiling difficult to ensile materials, especially wet or low sugar fodder plants which may also have high buffering capacity. अब ये होता है कि फॉर्मिक एसिड जो होता है वो ऐसे मटेरियल जिनकी ensiling is a difficult task, which are difficult to ensile materials, उनकी ensiling के लिए बहुत अच्छा suited होता है उनके ensiling के लिए. Now for the wet or low sugar fodder plants के लिए and ऐसे जिनकी बफरिंग कैपेसिटी हाई होती है उनको भी, यानी उनमें एडिशन ऑफ जो है वो एसिड या बेस का कोई डायरेक्ट इतना इफेक्ट नहीं होता, उनकी पीएच में इतना फ़र्क नहीं पड़ता, तो फॉर्मिक एसिड उनके लिए बेस्ट होता है, एक्सीलेंट होता है. फॉर्मिक एसिड इज़ यूज्ड टू रेस्ट्रिक्ट द फर्मेंटेशन व्हेन एनसाइलिंग क्रिम्प्ड हाई मॉइस्चर ग्रेन. क्रिम्प्ड होते हैं कॉम्पैक्ट किए हुए, वही बात दोबारा, ये वेट कंडीशंस के लिए बेस्ट होता है. तो फॉर्मिक एसिड जो होता है ये यूज़ होता है रेस्ट्रिक्टिव फॉर्मेशन के लिए व्हेन एनसाइलिंग, जब आप क्रिम्प्ड कॉम्पैक्ट हुए हाई मॉइस्चर वाले ग्रेन्स की एनसाइलिंग कर रहे हो तो फॉर्मिक एसिड जो होता है वो रेस्ट्रिक्टिव फर्मेंटेशन जो है वो उसके लिए यूज़ किया जाता है. Food and beverage industry byproducts such as spent mash from the breweries can be preserved with the formic acid solutions to give long shelf life animal feed. Now फूड की जो इंडस्ट्री है, जो ड्रिंक्स की इंडस्ट्री, उसके जो बाय प्रोडक्ट्स होते हैं उनमें स्पेंट मैश दैट इज़ कंज्यूम्ड मैश मतलब है वो जो ग्रेन्स को मैश करके जो उनको पल्प में कन्वर्ट कर दिया जाता है, उनको क्या कहते हैं, उनको पीस के जो है वो पल्प सा बना दिया जाता है. स्पेंट मैश ग्रेन्स का स्पेंट मैश होता है. तो उसको स्पेंट मैश जो oh my god now how animal biomass the use of formic acid for animal biomass. Animal biomass can also be preserved with formic acid. जैसे हमने silage को preserve किया, animal biomass को भी कर सकते हैं. The largest use in processing fish industry byproduct to produce fish silage. If we are going to produce a fish silage, we can use in the fish industry also. Fish industry byproducts can also be used to produce the fish silage. Proper treatment of fish offal is often required by environmental laws, and production of fish silage can be economically feasible solution. Now what is happening that जो fish offals होते हैं, जो भी उनके excretions होते हैं, जो भी उनके body parts जो कि dead जो fish हो जाती हैं, उनके जो body parts होते हैं, उनको environmental laws के according proper treatment देना होता है. और फिर और फिश साइलेज की जो प्रोडक्शन है, अगर हम उस चीज़ से उनके बॉडी पार्ट्स उनके जो ऑफेल्स हैं उनकी बजाय उनको किसी फेंकने के उनको हम लोग फिश साइलेज के लिए यूज़ करेंगे, दैट विल बी अ वेरी फिजिबल सोल्यूशन. इकोनॉमिकल भी होगा और साइलेज भी प्रिपेयर हो जाएगा. फिश साइलेज इज अ लिक्विड प्रोटीन रिच प्रोडक्ट मैन्युफैक्चर्ड बाय लोअरिंग द पीएच ऑफ द ग्राउंड फिश पार्ट्स विद एसिडिक प्रिजर्वेटिव्स. अब फिश साइलेज की थोड़ी सी क्या कंपोजिशन होती है, वो लिक्विड होता है, प्रोटीन रिच प्रोडक्ट होता है. और बनता कैसे है, जो फिश के ग्राउंड फिश पार्ट्स होते हैं, जो अच्छी तरह पीसे हुए पार्ट्स होते हैं, उनकी पीच पहले लोअर कर दी जाती है और एसिडिक प्रिजर्वेटिव्स के साथ. और इन कंडीशंस में, अंडर दीज कंडीशंस, एंजाइम्स फ्रॉम फिश इंटरनल्स प्रोड्यूस द फाइनल लॉन्ग शेल्फ लाइफ प्रोडक्ट इन अ फ्यू डेज. अब इससे क्या होता है, जब एसिडिक प्रिजर्वेटिव्स के साथ उनको ऐड कर दिया जाता है, उनकी पीएच लो कर दी जाती है, तो there are enzymes present in the fish internals. So those enzymes will produce final long shelf life products in a few days. In a few days will be required